My dear students, today we will discuss a few more concepts related to network analysis and control system. Few more concepts we have left in this subject, that is some concepts related to fifth module. We will discuss since could not have I could not get time to discuss all the concepts. Therefore, today I am making this video lecture related to fifth module of network analysis and control system. In fifth module, we will discuss some concepts like that is Routh-Hurwitz criteria of stability, Routh-Locus criteria of stability and analysis, and analysis using Bode plots. That is only three concepts. That is Routh-Hurwitz criteria, Routh-Locus criteria, and Bode plot. In fifth module, we will discuss only about these three concepts. That is fifth module about related to stability analysis. Stability analysis means what? What is stability? Stability means suppose a system is there. Suppose system is there, then if you take any system, television system, fan system, any system is there, then it should work, it should be stable, and it will be stable for a longer time. Stable means if some so it stable means, for example, if there is temperature change, some if it should work in particular temperature. If it the fan or something, tube light or something, some television, it should work, it will operate here also. If we take to some places where temperature is low, for example, other where temperature will be of 5 degree, 10 degree, or in other places where temperature will be 45, 46 degree, there also these systems should work properly. That is stability means, and it should work for a longer time. Suppose you purchase a fan, it should minimum, it should work for 3 to 4 years. That is, the system should be stable. Then for that, to any manufacturer is there, some fan manufacturer or car manufacturer or bike manufacturer, when they manufacture, I mean, they should know the system should work for a longer time. Uh, it should work for a longer time. Suppose you make some fan or something, if so within 1 month some damage happens inside the fan, then what is the use of purchasing a fan? But even though the temperature changes, even though small variation in the current, even though some small variation in the voltage, there should not be any problem or damage should happen to the fan. Like if you take example, I'm taking, you take any system. System means that is fan is system, television is system, bike is system, car is system. Like for that, here we have to analyze the stabilities of the systems. Therefore, analysis for here, to analyze already in the control systems, we have discussed so many concepts. What are the classification of the control systems? So many systems are there: closed loop system, open loop system. So many systems are there. We have discussed in the third model, we have discussed about classification of the systems. Then those systems should be stable for a longer time. To analyze that one, we'll discuss in fifth model, we'll discuss about stability analysis. In that, we'll discuss about Routh-Hurwitz criteria first, then Routh-Locus criteria, then Bode plot. In this video lecture, I will discuss about Routh-Hurwitz criteria of stability. What is this Routh criteria of stability? Let us discuss about the Routh-Locus stability, then stability analysis and control systems. Therefore, in this we will discuss about concept of stability. When system will be stable, all this we'll discuss. And here we'll come across some plots, um, some concepts like poles and zeros. That is poles and zeros. Then these are the, suppose this is a transfer function. This is the transfer function of a system. Then the roots of the characteristic equation of the numerator is it will tell about the how many zeros are there, and the denominator term denotes the poles and zeros denote roots of the characteristic equation of a roots of a character equation of the denominator term represents the poles. Therefore, first before that concept, we should know what are the poles and what are the zero. What we mean by pole, what we mean by zero. Therefore, here we come across to discuss that one related to stability analysis. We should know the Laplace transform. Here we should know the Laplace transform. We should know some what about the poles, what are the zeros, and in Laplace transform we'll discuss the concepts in S-plane. For example, nature of the closed loops. If nature of the closed loop system, if suppose this is the nature of the, if it is real negative left hand side of the aspect, suppose poles are here, poles location of the closed loop poles here on the left hand side of the S plane, then this system we call as absolutely stable. This such systems will be stable. Here we will come to know the stability of the system depending on the poles will tell the about the stability of the system. Here you see that cross mark, this tells about the, these are the poles, these are the left side of the S plane, left side of the S plane, and this is real axis, this is imaginary axis. Therefore, their poles are denoted by cross marks. Therefore, if poles tells about the system is stable or unstable. Unstable means it will not work for a longer time. If stable means it will work for a longer time. Therefore, if the here nature of closed loop, if of loop poles are real negative, that is in left hand side of S plane, then system will be stability conditions absolutely stable. Suppose the nature of closed loop poles are complex conjugate with negative real part, that is in the left hand side plane, it is like this, the poles are left hand side, then the system is also absolutely stable. Suppose the poles are real positive, that is RHS of S plane. If so, any pole is there on the right hand side of the S plane, then system is unstable. The means the pole should be left hand side. If it is right side, then we will tell that the system is unstable. Therefore, like so here they have given when the system will be stable, when system will be not unstable, everything they have given here. Means the stability of the system depends on the poles, whether it is on left side or it is right side. It depends on that. If it is on the left side of the S plane, then the system will be stable. If it is on the right side of the S plane, the system will be unstable. Therefore, we should know about what are poles, what are zeros. Then we will discuss about Routh-Hurwitz criteria. Routh-Hurwitz criteria. In that, we will discuss in detail about the Routh's criteria, Routh stability criteria. Routh stability criteria. In that, here, suppose this is a, consider the general characteristic equation as Fs is equal to some equation is the characteristic equation as f of s equal to a naught s raised to n plus a1 s raised to n minus 1 plus a2 s raised to n minus 2 plus like this some equation is some characteristic equation is there. Then here you see this equation. In this equation a naught a1 a2 a3 like these are the coefficients of this Sn n minus 1 like these are the coefficients a naught a1. Then how we can find out the stability of a system? By analyzing these coefficients. By analyzing these coefficients, we'll come to know the system is stable or not. Then we will form a method of forming an array. We will form an array where we will represent Sn minus 1, s raised to n minus 2, s raised to like this will represent. Here it will represent a naught, a2, a4, a1, a3, a5, b1, b2, b3, c1 like we will represent. These are the coefficients a naught, a1, a2, a3, a4. These are the coefficients of what? Coefficients of these characteristic equations. Therefore, then we know that from this we will obtain the coefficients of all a naught, a1, a2. What about this b1, b2, b3? Therefore, b1, b2, b3, for that some equations are there. How we can obtain the coefficient b1? That is, already we know the coefficients of a1, a2, a3, like we know that one. Then from those coefficients, we can obtain the b1, b2, like b3 will obtain this. This b1 is what? Nothing but how we'll obtain the coefficient b1 here in this equation. The b1 is nothing but a1 into a2, a1 into a2 minus a0 into a3 divided by a1. This is nothing but from this we'll obtain b1. Substitute the value of a1 here, a2 here, then substitute the value of a0 here, a3 here, then we'll get b1. Similarly, substitute how we'll get the coefficient of an array b2 in the that one, that is this is the equation to calculate the b2 coefficient, that is a1 a4 minus a0 a5 divided by a1. How will get b3? B3 is nothing but a1 into a6 minus a0 into a7 divided by a1. Like we'll get the coefficients of what in this array of coefficients of b1 b2 b3, because in this from this characteristic equation we'll get the only the coefficients of a naught a1 a2 a3. We nowhere they have not will not get b1 b2 b3 or c1 c2. How will get b1 b2 b3 means from this equations, from these coefficients. Like similarly we'll get how we'll get the coefficient c1 c2 c3. For that also some equations, some expressions is there, some equations is there. From that how we'll obtain the c1 c2s, we'll get that one. How we'll get c1? Already we have obtained b1. b1 into a3 minus a1 b2 divided by b1 gives the value of c1. Similarly, how we'll get the coefficient C2? This is C2 equal to B1 A5 minus A1 B3. A1 B3. Already we have obtained B3 here. From that B3 substitute here, we'll get the value of C2 here divided by B1. Like this, we'll obtain all the values, coefficients. We'll get the coefficients here, and in these coefficients, if this is the first column of the array, this is the first column. Here in this array, suppose when we substitute the values, if all the values are positive, if there is no sign change, then we can tell the system is stable. If any sign change means, suppose this is positive, this is positive, but while getting this value, suppose we get negative value, then this will get positive value, then there is sign change, minus to plus, plus to minus, then this system is not stable. Therefore, this column is important. First column, there should not be any sign change. Then, if there is no sign change, then we treat it as stable system. If there is sign change, from positive to negative, negative to positive, then such systems will tell such systems are unstable. For example, here Routh's criteria. The necessary and sufficient condition for system to be stable is all the terms in the first column of Routh's array. Routh's array is this is Routh's array must have same sign. All signs should be same. There should not be any sign change in the first column of the Routh's array. Sign change means positive, negative. So all should be positive. There should not be any sign change. That then at that time, if there is no sign change, then we call such systems are stable. If there is sign change, then at that time we will not tell this system is unstable. For example, we'll see an example. Example will come to know the how we will find out the stability using Routh's criteria. Examine the stability of a given equation using Routh's method. Examine the stability of a given equation using Routh's method. In that, for example, this is the equation. This is the characteristic equation of a system. Equation means simply it representing a behavior of a system. Then suppose by analyzing this equation, we'll come to know whether the system is stable or not. Therefore, here s3 plus 6x2 plus 11s plus 6 equal to 0. From this expression, we'll get the coefficients of what? Coefficients of a0. A0 because this is a0. This is a1. This is a2. Like this we'll get. A0 is how much? There is no suffix here, no prefix here. Then this is a0 will consider as 1. What is a1? A1 is equal to 6 because here this is 6. Then what is a2? A2 is here. 11 is a2. A3 is what? A3 is nothing but 6. And n is what? N equal to 3. Here n represents, here n means which is the highest order. So this is s to 2, s to 3. Highest order is tells about n, that value is will treat as n is equal to 3. Then now we'll draw the what will draw the root will form a root array will form. How will find out the how will draw the array? This is how much the highest order is 3. Therefore s3, s2, s1, s0. Then in that what values we have to substitute? Here you see here this array is very important. From this we'll come to know what values we have to substitute. First value should be a0, second value should be a2, third value should be a4. Like this you should know this array. Array, then only we can place the values in this array. Now what is your a0? A0 is 1. Therefore first we'll place 1. Then what is next value? Next value should be a2. What is your a2? A2 is 11. Therefore we'll place 11 here. What should be your third value? A4. A4 here, what is, how much is the a4? No a4. Then we'll substitute no well means we will not consider that one. Then next value should be, this is a, next is what? Next is what? A1. Here A1 is what? A1 is 6. Therefore we'll substitute 6. Then what? Then A3 is what? Then A3. A3 here in this equation, A3 is what? 6. 6, 6, 6. Then 6. Here A1 is how much? A1 is 6, right? Then this is here A3 is how much? A3 is how much here? A3 is also 6. Here A1 is also 6, A3 is also right. 6, 6. Then this is coefficients you obtained. Then this is how much? How will this is what? This is your B1. This is your b2. How will get b1? The equation is there to calculate b1. b1, how we can calculate? Place the values of a1 a2 here, minus a0 a3 divided by a1 gives the value of this. Here, what is here? You see this one, b1 equal to, first we'll write the equation that here I written this. No, b1 b1 equal to how much? b1 equal to a1 a2 minus a0 a3 divided by a1. Therefore, here how much is the a1 is 6, a2 is how much? 11. Then then how much this is? a0 is how much? 1 into, then this is our a3 is how much? 6 divided by a1 is how much? 6. Therefore, here we'll get that is here. Therefore, here we'll get b1 equal to a1 a2 minus a0 a3 divided by a1. A1 value is 6 and a2 value is 11 minus a0 value is 1 into 6 divided by 6. Then this is how much? This is 66 minus 6 divided by 6. Then it will be 60 divided by 6. Then its value is how much? No, sorry, 66. 6. Right. Then this value will be how much? 0. 60 minus 6 value is 10. Therefore, here you see the value is 10. Now b1 value is 10. Then what is b2? b2, how will get the value of b2 here? b2 equal to a1 a4 minus a0 a5 divided by a1. Therefore, here what is the value of a1 here? a1 is how much? 6. 6 into a4 is how much? a4 is 0. Therefore, 0. a0 is how much? 1. 1 into a5. I think a5 is there here. A5 is how much? 0. No a5. 0. Therefore, a1 is how much? a1 is 6. Therefore, this is the equation. In this, this is 0. 6 into 0, 0. 1 into 0, 0 divided by 6. Therefore, 0 by 0 into 6 equal to 0 by 6 equal to 0 only. Therefore, b2 will be 0. b2 will be 0. Like we got the value of b1, b2. Now, what is the value of c1? c1, what is the equation for c1? c1 is nothing but c1 equal to b1 a3 minus a1 b2 divided by b1. Then what is the value of b1 here? b1 is so much? b1 value is 10 and b3 value is how much? What is a3 value is how much? 6 minus, then what is the value of a1 is how much? 6. Then what is the value of b2? b2 is how much? b2 is 0. b2 is 0. Therefore, then divided by b1 is how much? 6. Therefore, this is here will get what is 10 10 10 we get here 10 60 minus 0 divided by 60. c1 is equal to a1 b1 is how much? 10 a3 is how much? c1 is equal to c1 is equal to b1 A3 minus A1 B2 divided by B1. That is A1 is how B1 is how much? B1 is 10. 10. Then A3 is how much here? A3 is 6 minus. Then A1 is how much? A1 A1 is 6. Then divided by B1. B1 is how much? Here B1 is how much? This is your B1. B1. Therefore, this is 10. This is here 10. That is 10. 10 into this is your B1 into A3 minus A1. This is B1 is 10, A3 is 6, minus A1 is 6, and B2 is 0. Divided by a B1. B1 is how much? 10. Therefore, 60, 0 into 6 into 0, 0. Therefore, 10 into 6, 60. 60 minus 0. Therefore, it becomes 60. 60. B1 is how much? B1 is 10. Therefore, 60 minus 10, it will be equal to 10. This. But we got 6 here. Sorry. Here, sorry. Here, 60 minus 0, 0 get cancels. Sorry. 60 by 10, how much? 60 by 10 is 6. 0 get cancelled, you are left with, this is wrong. 6. 60 by 10 is 6. Therefore, here we place value 6. Like C2, we will get C2 here. C2 similarly, we get the value of C2. C2, how we will get, what is the equation to calculate C2? C2 equal to B1 A5 minus A1 B3 divided by B1. But see here in this equation, we don't have the values of A5. A5 is not there here in this equation. Also, we don't have B3. B3 is not also there. Therefore, in this, we will not consider C2. Only will consider C1. Therefore, you see here the first column of this equation. Here you see first element is 1, second element is 6, third element is 10, fourth element is 6, and all these elements are positive. Therefore, since you see here, as there is no sign change in first column, the system is stable. If you see here this example, this example, take the coefficients, find out the coefficients, and calculate here. While calculating the values of b1 and b2, c1, c2, there is sign change. Why? Because while calculating b1, 4 minus 16 will be there divided by 4. Then what happens? It will be 4 minus 16 is how much? To minus 12. Minus 12 by 4, it becomes minus 3. Therefore, in first, after calculating all the things, here this is positive, here this is positive. What about this element? This is negative. After the, what about this element? There is a sign change. Here sign change, here sign change. Positive to negative, negative to positive. Therefore, as there are two sign changes, system is unstable. The first columns, there should not be any sign change. Then only we can call this system as stable. If there is sign change, then we call this system as unstable. This is how from Routh's criteria you will come to know about the stability of the system. Stability is important. This is in that we'll have special cases. This is also important. Suppose in the first column we suppose following in we suppose while calculating the elements of the first elements of the first column of the array roots array, if infinity comes, following two methods are used to remove above said difficulties. Here suppose infinity comes, then the condition fails. The analysis is difficult to analyze whether the system is stable or not. At that time, we have to consider in the place the infinity arises because of the term zero came to in this element in this row. Therefore, we have to avoid zero in the first column. Therefore, what we have to do, we have to take a small value called epsilon, and we have to place the epsilon in place of 0. In place of 0 substitute, and that should be the value should be 0. That epsilon should be so small value so that it tends to infinity. Sorry, it tends to 0, means so small it is nearly equal to 0. Then taking that value we can solve the problem of infinity here. That in this equation, solving this equation, suppose you take the epsilon here, then calculate, this will be the value of b1 and b2. While calculating b1, then c1, we know the equation, how we can calculate c1 here, we'll get the value of c1 here, like this. That next we'll get the value of c2 here, like this we'll get the c3, like this will go. This is C, like c1, like we'll go get the all the values here. Suppose you see here, you suppose you analyze this expression here, this expression, the 6 epsilon minus 3 divided by 6, take this outside, then minus limit epsilon tends to 0, 3 by 3 by epsilon. Since the epsilon tends to 0, means here you substitute the value of 0 here. 3 by 0 is what? Anything divided by 0 will be infinity. Therefore this is infinity and this is minus. Therefore anything, this is so small that compared to infinity, therefore we will consider this term as minus infinity. There is a negative sign, is negative here. Therefore, after calculating all this, here since there is sign change, when you substitute that one, this sign change from positive to negative, negative to positive. Therefore, as there is two sign changes in the first column of the root array, then the system is unstable. This is important. Such questions will be asked in exam. Not that these exams, simple exams, they may not ask. Such examples may ask. Therefore, you refer the special cases. Special case 1, special case 2. Special case 2, in special case 2, what happens? Suppose all elements of the row will be 0. At that time it is difficult to analyze row of zeros. Special case, it is difficult to analyze analyze the system. Therefore at the time what we have to do, we have to take special cases, and at that time to eliminate the pressure, to eliminate the difficulty, what we have to do, we will take an expression, what is called as auxiliary equation. We will take an equation that is called as auxiliary equation. In that we will take a of s equal to d of s of s raised to 4 plus e raised to s of 2 plus f. Here this how we'll get means, this is the here where we got to the zeros. Here zeros, we have to consider the above elements, and this is what is d of s of 4. This is e of s of s raised to 2, d into s raised to 4 plus e into ss to 2 plus f. Then these elements of this row are replaced by these values, that is a of s equal to ds4 plus ss2 plus f. Then we'll differentiate this equation. We'll differentiate with respect to ds. Then d of a, differentiate this equation with respect to s, means here you see, here when we differentiate, what happens here? Differentiation with respect to s means 4 comes is that 4s raised to 3, 4 4d s raised to 3. Then this will be 2es. What about this f? F is nothing but, here it is constant. What is the differentiation of constant? Value of that will be 0. Therefore, we will not consider differentiation of any constant will be 0. Therefore, we will not consider this as. Therefore, ultimately, what we got, it is the elements, the coefficients we got, coefficients of four next elements in the row. That is 4d, 2e, 4. Then we'll write those in that row where zeros were there. In that we'll write 4d, 2e. Here no value is there, therefore substitute this value 0. By using this auxiliary equation, we can solve the problem of when all the zeros will be, all the elements in the row are 0, when it is difficult to analyze the root array. At that time we will consider the special cases. Some examples are also there on the special cases. Suppose in the exam they will ask, they may ask related to these special cases. Special case 1, when infinity comes, then how will solve that problem? We suppose all zeros are there in the row, how will solve the problem? Whether the system is stable or unstable. At that time you have to know all how we have to solve this problem, and how will come to know the system is stable or unstable. This is about roots. Here they have given so many problems. Roots solve problems, so many problems, whether the system is stable or unstable. Like so many problems are there. Therefore, at beginning in the class only, I told that we refer the book, that is Control System by Bakshi. This book is very important. Your Control System by V.A. Bakshi, V.U. Bakshi. This book is V2 books, some simple books, V2 books written by V.A. Bakshi and V.U. Bakshi. It is V2 books, simple books. All the concepts of a third module, fourth module, fifth module, it will cover all the 3 modules. Important. Beginning only I told that you refer the books, V2 books. So simple, you can understand the concepts very easily. Everything easily you can understand the concepts. Like so many problems they have given related to Routh-Hurwitz criteria. Then okay, this is about you see that one. One simple example I explained here. The rest of the things, rest of the problems, you have to think and you have to solve, and you only analyze the problems. Next, this is about Routh-Hurwitz criteria. Then, as I already told that that is in the fifth module, that is Routh-Hurwitz criteria, and one more is root locus criteria, one more is Bode plot. 3 concepts only, very important, that that we'll discuss. That is one by one. Today I have discussed that one. In next video lecture I will discuss about the stability criteria, using root locus method, how we will find out the stability of a system. In another video lecture I will tell, using Bode plot concept, how will I analyze the stability of a system. Okay, since because I have not covered in the class, I am doing such this video lecture so that you can understand the concepts. You also read very important concepts. Definitely they will ask an example questions related to root Hurwitz criteria, concepts related, problems related to root locus criteria, problems related to Bode plot. Important. Definitely, such problems will be asked on such concepts. Okay. Okay, next video lecture I will discuss about how we'll plot the root locus. What are the steps are there to get to generate or to get the root locus. All the concepts I will discuss in the next video lecture. Okay, okay. Thank you.